Okay, so very good afternoon to all. Welcome for the lecture number 15 for of petroleum refining technology. So in the last class, we have seen about the various kinds of the testing and specifications for the various kinds of the petroleum product that was related to the gasoline, kerosene, naphthas, and what can the different kinds of the test that can be done for that particular video that we have seen in the last class. Now in today's class, we are going to see what are the important properties of a particular petroleum fractions and how these particular properties play a vital role while defining any kind of the petroleum products. So these properties and these are the testing specifications that are to be most important aspects for that, and that is going to play a major significant role in that particular part of calculations. Okay, so first of all, let us share the screen. Let us share the screen. Okay, now these are the properties of particularly petroleum fractions. Okay, these properties include certain flash point, cetane number, octane number, and various kinds of properties are also available. Now, the first property, which is an important property for any kind of the fuel, that is the flash point. Now, what is flash point? Flash point, it is the minimum temperature at which, okay, the vapors from the sample oil, or you can say from the petroleum fraction, will give a momentary flash when it is ignited. Okay, it is the minimum temperature at which the vapors from the oil will give a momentary flash, momentary flame, okay, when it is ignited. That is simply called as a flash point. In another definition, flash point is defined as that temperature at which the oil will ignite when it is exposed to the flame. When it is exposed to the flame. So suppose we have one candle, okay, we have taken one candle, and within this, suppose the candle has formed a flame, and if I consider the oil, if I bring that oil in front of that particular flame, then it will start to ignite, and the temperature at which it is going to start to ignite, that can be measured with the help of thermometer. That is simple measurement, and that is called as a flash point. So there are n number of devices are used to measure these particular flash points, and these flash points plays a major role in case of particularly forming the flashpoint apparatus. Now, this flashpoint is actually determinant of flammability of the petroleum fractions. Okay, so this flashpoint mainly determines the uh, flammability of the petroleum fractions, and according to that, some of the petroleum fractions are classified based on its flammability of that material, and this test is a measure of cleanliness of the fuel. Okay, because what happens that when many times when oils are there, and these particular oils especially forms particularly you can say uh, we can say that they are forming certain black colored fumes. Okay, these black colored fumes are very dangerous, so that's why the tendency of a fuel to measure its cleanliness, that is also determined based on the flash point. So this flash point also gives the flammability of the mixture or flammability of the single component. Majority is determined for the single component for consideration, and these are very good properties that can be seen over that particular point, and that we call as a cleanliness of that particular fluid. Now there are n number of martins, n number of equipments are available to measure the flash point. Even you can measure also flash point in the laboratory of ours available in fluid flow operation lab. Different scientists have given that measurement. One was Abel, another was Penske Martin's apparatus, third was Cleveland apparatus. Okay, these are the various parts scientists. So out of that, Penske Martin apparatus is generally known. Even if you go with SPPU, okay, in quality control labs, okay, this made measurements are also available. Analytical laboratories. Okay, able apparatus is there, Pensky Martin's apparatus is there. Okay, Cleveland apparatus is there that can produce. So in this apparatus, actually there is a possible fire hazard during the transportation and storage and handling. So the possible fire hazards during the transportation of any crude oil, during its storage or during its handling, can be predicted based on the flash point. So generally flash point should be kept above 42 degrees Celsius. Okay, so when you are performing with the experiment related to either biodiesel or either biofuel, okay, you are able to see that this flash point should be above 42 degrees Celsius. And here the test sample should be filled up to the mark. Okay, the test sample should be filled up to that particular marks. So test sample must be filled up to that particular mark. So on Pensky Martin apparatus there is a mark, as like we have in our measuring cylinder, we have marks 100 ml, 200 ml. Similar way there are marks, okay, for the volume of the fluid which can be exposed to the flame. For that, the temperature of the oil is slowly and uniformly raised by 3 degrees Celsius per minute, and based on the volatility of the fluid, okay, the scientist able has used the high volatility sample whose velocity is less than at 40 degrees Celsius across this. Okay, even in Pensky Martin apparatus, generally he has used closed loop cup. Okay, he has used closed loop cup used for the medium flash liquid. He has used closed loop cup for medium flash liquid. For that has been utilized. And here, this Pensky Martin apparatus that can be used as a medium flash liquid for that particular content that was going to be utilized. Next was open cup was used. So open cup was used for high flash points. Okay, for getting the higher flash points above 50 or 60 degrees Celsius, we are going to use open cup use that we are going to use for that purposes. So this was regarding the flash point apparatus what we have, okay, for considerations. So these flash points is again at the temperature at which the oil will or petroleum fraction will ignite when it is exposed to the particularly flame that is going to take under that particular consideration. So three apparatus can be used: Able apparatus, Pensky Martin apparatus, and Cleveland apparatus. Out of that, majority Pensky Martin's apparatus is commonly utilized in case of that particular properties. Okay, now the next property what we have is a fire point. Okay, fire point is another property. So flash point and fire point, these are combinedly defined, correct? Okay, so flash point, fire point is closely going to follow with the flash point. So fire point is also known as combustion point. Okay, fire point is also known as combustion point. Okay, and it is defined at the lowest temperature at which the vapor produced of that oil will continue to burn at least for 5 seconds after ignition by an open flame in a standard dimension vessel. That is called as fire point. So flash, as I told, that this flash point is fire point is going to follow the flash point. Here the important aspect of the thing is that when the vapor of that oil is produced, that vapor of the oil will continue to burn at least for 5 seconds. Okay, when it is ignited by an open flame of standard dimension. When it is ignited by an open flame of standard dimension. So that is going to be taken under that considerations. What we call after an open flame on standard directions. Is it clear? So that is what we call as fire point. And this tests of the fire point, actually it is carried out in open cup. Okay, it is carried out in open cup rather than in closed one. In flashpoint test, all flashpoint tests are majorly carried out in a closed cup systems. Okay, but fire points are somewhat higher. Okay, that's why the fire point tests are always carried out in case of open cup, especially in the Cleveland apparatus. Okay, especially in the Cleveland. Cleveland is the name of the scientist who has invented this particular test, and this is American Society testing machines D92. ASTM D92 is the specific test that is used for calculating that particular fire point. Okay, so just remember that